Hi everybody. So in this video, we're going to look at finding the equation of a circle. So in example 1, we've been asked to show that the equation of a circle of centre AB and radius r has this equation given here. So the first thing we're going to do is we're going to look at a circle which is centered on the origin, so in this circle here. And if we were to take a line from the center to any point on the circumference, we'll call this point P. Then we have a radius of that circle. We'll call this r. And this point P is located at any point we'll call x and y. So a general x value and a general y value. And we can see this r as a right angle triangle, where the adjacent side will have a length of x. And the opposite side, or the height of our triangle, will have a length of y. And this will be a right angle. And because it's a right angle triangle, now we can use Pythagoras' theorem, where x squared plus y squared will equal the radius squared. And we should be familiar with this equation of a circle from our GCSE mathematics course. And at A level, the circle is translated, so the centre is no longer at the origin. So if we think about this triangle, we can say its centre will have a general point, A and B. So this will be A on the x-axis and B on the y-axis. We can apply exactly the same idea. So if we pick a point on the circumference, we'll call it point P. This will have an x and a y value. The distance from the center to the circumference, we know is a radius. And the height of our triangle will be the y value, which is this length, minus this length, minus the b value. So this will be y minus b. And the adjacent length of our triangle will be the x value. So this length minus this length, which we'll call x minus a. So again, using Pythagoras' theorem, we know x minus a all squared plus y minus b all squared will equal the radius squared. And this is the general equation for a circle whose centre is not at the origin. And we'll be using this equation as we progress through the examples in the video. Okay, so in example 2, we've been asked to work out the equation of each circle when we're given its centre and its radius. And we know that the centre is located at AB and the radius is the distance from the centre to the circumference. So we're going to use this formula. Okay, so for part A, we can see that our A value is this 3, the B value is this 1, and the radius is given as 5. So the equation of this circle then will be x minus a, x minus 3 squared plus y minus b, so y minus 1 squared. And this will equal the radius squared, so 25. So do you want to try and work out the equation of the circles for parts B and C? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So for part B, we can see that the A value is now 4, B value is now negative 6, and the radius is 1. So the equation of this circle, x minus a plus y minus the negative 6, and the negative minus becomes a positive, so y plus 6 squared, and that will equal 1 squared, or just 1. And then for part C, we know the a value is given as 2n, the b value is given as 7n, and the radius is given as 5n. So we'll have x minus 2n squared plus y minus b, and b is 7n, all squared, and this will equal the radius squared, and 5 squared is 25, and n squared is n squared. So this will be the equation of a circle in part C. Okay, so for example 3, we've been asked to state the centre and the radius of each circle. So now it's about working the problem the other way around. We can see that A is given as 5. So the centre, A is equal to 5, and that this B value must be a negative 4, because when you have Y minus negative 4, it needs to become a positive. So Y will equal negative 4. And the radius squared is 25. So the centre will be at 5, negative 4, and the radius will be 5. And do you want to try and work out the centre and the radius in example 3b? You can pause the video, and when you come back, we'll go through the work solution. Okay, so for 3b, we know that A is going to be negative 2, B will be negative 1, and R squared will be 81. So the centre will be at negative 2, negative 1, with a radius of the square root of 81, 9. Okay, let's move on to example 4. Okay, so for example 4, we've been asked to state the centre and the radius of each of these circles. And these are presented in the expanded form. You can see that the original form has brackets, and in this form the brackets have been expanded out. So we need to go back from this form to our general form here. And we can do this by using the method of completing the square. So if we look at example A, we've got our x squared terms and no other x terms. So we'll just have x squared. But now we've got a y squared minus 6y. And we can use completing the square to write this as y minus 3 all squared. But then we need to take away this 9, because when you expand this out, you get a positive 9, which we need to take away. Now we've got back to this part, we need to add on the 5, and this will equal 0. So we can tidy this up by collecting these like terms. We've got x squared plus y minus 3 squared. And then we can move this negative 4 to the right hand side, and this will become equals 4. So you can see that the a value is 0 and the b value is 3. So the centre will be at 0, 3. And the radius will be the square root of a 4, which is 2. Let's try question B. So if we use completing the square with the x terms, we'll write it as x plus 6 squared. We'll complete the square by taking away the 36. And then the y terms, well, we've got y squared minus 8y, so y minus 4, which will square, and then we'll complete the square by taking away the 16. So both equations are equal. Now we can tidy this up by collecting these like terms. This positive 36 will cancel with this one. So you've got x plus 6 squared plus y minus 4 squared. And then we'll move this negative 16 to the right hand side. So the centre, we can see that the a value will be negative 6. The b value will be at positive 4. And the radius will be the square root of a 16, which is 4. So do you want to try and work out the centre and the radius for question C? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So the first thing we're going to do is we're going to tidy this up and put all the terms on the left-hand side. So we'll have 2x squared. We'll move these positive 7 to the left-hand side by taking away 7x. So we'll have negative 12x. We'll move these negative 4y's to the left-hand side. So 2y squared plus 12y. That's the 8y, add the 4y. And then we'll move this negative 4 to the other side to make positive 4. Now we can see we can factor out with 2. So we've got 2 lots of a squared minus 6x plus y squared 6y plus for 2 will equal 0. We'll divide both sides by 2. Plus for 1. And then we can use the method of completing the square. So we've got x minus 3 squared, take away with 9, plus y plus 3 over 2, take squared, take away the 9 over 4, plus 1 will equal 0. We can tidy this up by writing that 1 as 4 over 4. So we've got x minus 3 squared plus y plus 3 over 2 squared. Then we've got the negative 9 plus for 1 minus 9 over 4, which gives us minus 41 over 4, and this will equal 0. So finally, we'll move this term to the right-hand side. Plus y plus 3 over 2 will equal 41 over 4. So we can see our centre is at 3, the x-axis, and minus 1.5 on the y-axis. And the radius will be the square root of 41 of the square root of 4, which is 2. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.